Exponent rules. Hopefully exponent rules is going to be kind of just a refresher from you, because I think you've learned exponent rules all the way back from like algebra 1.
Oh, yeah.
All right, so should not be any big surprises for today. Some of the questions do get a little complicated just because this is pre-calculus. And so obviously we're not going to see these baby type exponent rules questions. All right, that's not what you're going to get asked. You're going to be asked some of the more complicated ones, but let's refresh your memories first. So if you are multiplying, what do you do to your exponents? Add them. All right, so x squared times x4 is going to be?
X6.
X6. And what about x squared times y3?
X squared y3.
Yes, you cannot actually add those exponents. The bases do have to be the same when you are adding your exponents. Now, do you do anything to the base? No, the x stays x. All right, so the next exponent rule is when you are dividing, what do you do to your exponents? Subtract. And you are going to subtract the top one from the bottom one. So x5 divided by x3 is going to be?
X squared.
X squared. All right, and x2 divided by x3?
X 1 over x.
So technically, 2 minus 3 is negative 1. And we're going to write that as 1 over x. We'll talk about the negative exponents here in a second, but the way that I prefer to think about this when you're subtracting exponents is I think about I have 2 x's on top and I've got 3 x's on bottom. So when you cancel out 2 of them, you're left with 1 on the bottom. Does that make sense? So that's kind of how I think about the subtracting. I've got 2 on top, 3 on bottom, so I'm left with 1 left on bottom. All right, for this next rule here, when you have an exponent outside of the parentheses, what do? Multiply. And generally, not always, but generally, this is the first step when I'm simplifying. All right, 9 times out of 10, this is going to be the first step I do when I simplify. So on this one, x squared to the 3rd power is going to be x to the 6th. And if you have multiple things inside your parentheses, that exponent on the outside goes to all of the things. So x squared y5 to the squared power is going to be x4 y10. All right, negative exponents. Put it on the bottom. And generally, like I said, generally, this is my last step. So I don't mess with the negatives until the very, very end. And what the negative will do is it will move your guy from the top to the bottom of the fraction. So negative exponents are going to create fractions, not negative numbers. All right, negative exponents create fractions. So x to the negative 4 is really 1 over x to the 4th. All right, over here, remember I said negatives are going to be the last step. So I'm going to do the 2 first. So 2 times negative 3 and 2 times the y. And then I'm going to move the negatives to the bottom. So only x gets moved to the bottom, y gets to stay on the top because it is not a negative exponent. Y squared over x6. All right, the next one, this guy here, and on the negatives, those are probably the 2 biggest exponent rules that you're going to see in AP Calculus next year. All right, so negative exponents and the fraction exponents are the 2 things that you're going to have a lot. And so what the fractions are going to do is they're really just roots. The bottom number is the root. The top number is the exponent. And so I can rewrite this as the nth root of a to the m power. And if you think about it, plants and trees have roots. Where are the roots located? On the bottom, in the ground. So that's kind of how you can remember. If you forget which one is the root, think about where do roots go. They go to the bottom. All right, so on this one, if I were to rewrite this, what kind of root?
Square or cube root.
Cube root x squared. And then the y, what kind of root will the y have? Fourth root y cubed. Yes. And then the last one here, anything to the 0 power, no matter what it is 1. So no matter that all of this stuff here on the inside of the parentheses, since it's all being raised to the 0 power, it's 1. And then all of this stuff in the parentheses, we do not care. It's still going to be 1. All right, so we can use these exponent rules if you have the same base. So you do, that's like the very first example. You have to have, it has to be x squared times x something for it to work. All right. Oh, now I forgot to tell you, I think, I know your midterm, we talked about the midterm being on Eduphoria, right? The whole thing, it's 25 questions on Eduphoria. Most of it is multiple choice. You can use a calculator on the whole thing. So that's one of the good things about having it on Eduphoria is the whole thing is calculator. But that being said, there are some tricks that you can use to evaluate these expressions without a calculator that you probably will need to see in the future. So let's talk about those. All right, 8 to the 2/3. Remember, that is really just a root. So what kind of root? Yep, cube root of 8 squared. Mm-hmm. All right, so we want to do the root first. All right, it keeps the number smaller. So we'll do the exponent second. It doesn't technically matter, but it helps us keep the number small. So what's the cube root of 8? 2, and then what's 2 squared? 4. So your answer is 4. All right, on the next one. What does there hit my door. I need to turn it off. What does the negative exponent do? Makes it go to the bottom. So the 5 squared is going to go to the bottom. The 1 is going to stay on top. It's an understood one. And when it moves to the bottom, your exponent turns positive. So what is 5 squared? 25. So your answer is 1 over 25. All right, and now on example 3. The negative exponent is on the bottom. So when I move it to the top, it turns positive. All right, so when I move the 9 to the top, it turns to a positive exponent. Now, I don't like the fraction exponent, so I'm going to rewrite that as a root. What kind of root is it?
Square root.
Square root of 9 cubed. Now, I don't know what 9 cubed is. Remember, we're going to do the exponent last. So we're going to square root first. What's the square root of 9?
3.
3. And then what is 3 to the 3rd power?
27.
Alrighty, and then my last one here, and there's a couple different ways you could do this. You could get rid of your negatives by flipping them around, which that might be the easiest one. So I'm going to move this guy to the bottom, and I'm going to move this guy to the top to get rid of my negative exponents. And then what do you do to your exponents when you're dividing? Subtract. So that's going to be 3 to the what? 2. Now the 3 stays 3. So you don't do anything with the 3. 4 minus 2 is 2. And then what's 3 squared? 9. All right. Does that make sense?
Yes.
Awesome. All right. So let's go down here to example 5. And we're going to look at maybe some more complicated simplifying. All right, now remember, rule of thumb is get rid of your parentheses. All right, so I'm going to multiply the 5 and the 2 here, and I'm going to multiply the 10 to both of those exponents to lose my parentheses. So I have b to the 14th, c10, c10 over d10. Yes. So these guys will cancel out because you have a C10 on top and a C10 on bottom. So they will simplify and they will reduce and you can cross them off. And so on top I'm left with
B14.
and on bottom,
D10.
can you do anything with those? Nope. So that is your final answer. B14 over D10.
How'd it go, Miss Marcy?
All right, go over to example 7. All right, on example 7, this is one of the most common mistakes for exponent rules. All right, we are going to get rid of the parentheses, and so we are going to multiply the 3 halves. But the 3 halves has to go to all of the things on the inside, including the 16. Now, what is the exponent on 16?
1.
A 1. So 3 halves is not multiplying by 16. 16 is a big number. It is not an exponent. You have to multiply the exponent to another exponent. So they're exponent rules. So you can't do anything with the big numbers when you're doing exponent rules. Only with exponents. So 3 halves times 1 is going to be 3 halves. And then 3 halves times 4.
12, 6.
4 times 3 is 12. 12 divided by 2 is 6. So this is 16 to the 3 halves, not multiplying. All right, it is an exponent. And when you have fraction exponents, we don't ever like those, so we're going to write it as a root. What kind of root do I have?
Square root.
A square root. So what is the square root of 16?
4.
4. And what is 4 to the 3rd power?
So 64.
64. So 64A6. Okay, so let's go over here. Okay, I'm seeing this guy right here that I'm going to multiply. So 4 times 2, which is going to be
8.
8. Oh my gosh. Hold on, I can't listen to it again. I gotta turn it off. Someone keeps pressing my. I sang it. I need somebody else to sing to my door.
Out of nowhere on page 2. Oh, the
So I'll have to hear my voice all day long. On my door, there's a recording of my song. You know, where you press it, it sings.
What song?
The song I made. No, it's not 6-7, but it's a Jingle Bells to Calculus. All right. So next thing here that I'm noticing is I have -4r and -4r. So these bases are the same, which is so nice because what can I do to my exponents since the bases are the same? Subtract them. So what's 8 minus 11?
-3.
3. So I'm going to be left with
4.
What?
What? Wait, I'm that confused.
Oh.
It's because there's more on bottom. You have 11 on bottom.
There's 8 on top, but there's 11 on bottom, so you'll be left with 3 on bottom.
Why is it positive?
Huh?
Why is it positive?
Because it's on the bottom.
It's on bottom.
But 8
But
minus.
you still have 3 on the bottom.
That's like the X's thing that she showed. The X's down the bottom.
You good?
Yeah.
Okay, so now I'm on the next step here. Do we want to do 16 to the 3rd power? No. What else are we noticing that's the same?
The R.
They're both to the 3rd power and there are.
Yes, they're both to the 3rd power and they both have an R. So I am going to rewrite this with the 3rd power on the outside of everything. So it's like undistributed. Because now, simplifying here, the inside is way easier. What's -16 divided by -4? 4. And what happens with the R's?
Cancel.
They cancel. And then what's 4/3? 4 to the 3rd power.
64.
64. So all of that simplifies down to 64. That one was kind of a hard one. All right. This one is also kind of similar with the way that we can kind of be tricky with the simplifying. So I don't want to do 6 to the 15th power because that would be crazy and I would never ask that of you. So there's got to be something else that we can do. So I'm going to come over here and I'm going to do negative 3 divided by 18, which is 6. Mm-hmm. And if I have an n on top and n squared on bottom,
Just an n on the bottom.
an n on the bottom. All right, so I started simplifying here, this inside, and I got 1 over negative 6n to the negative 17th, and then this guy right here. Now, are the bases the same? No, but they're close, right? All I got to do is I got to move this negative 6n to the top. So what happens with the exponent when I move that to the top?
It flips signs.
Yeah, it changes sign. So then I'm going to go negative 6n. And now that 17 is going to turn positive. Right? Because when you flip things around, the exponent turns negative. So double negative would make it positive.
Okay. Put the 6 in, don't change.
Mm-hmm. Okay. So now the bases are the same. So what can I do to my exponents when my bases are the same?
Add them.
Add them. Which is going to give you squared. And so now I'm going to square both these guys. So what's negative 6 squared?
36.
And n squared is just n squared. Aha, tricky, huh? All right, flip it over.
That was true. He spent so much.
I am not going to do example 9 or 10 because they're all numbers and because on your midterm you can use a calculator. You could just type all of that in your calculator, but you also could simplify using exponent rules. But no, I do want to talk about 11 though, because 11 looks crazy because it has all the fractions and exponents and things like that. But all we're doing is multiplying. So what is the exponent rule when you're multiplying?
Yeah.
Adding. Now what can I add together? There's
X's.
the x's, yes. The only bases that are the same are the x's. So the only thing that you can add are the x exponents. So the 2 is going to stay a 2. The y to the 1/2 is going to stay a y to the 1/2. X is the only thing that is going to change.
11.
Yep, so 3/2. Oh, that was really ugly too. 3/2 plus 5/4.
That's probably less than that too.
Mm-hmm. So that's going to give you 6/4 plus 5/4, which is going to give you 11 over 4. And that's all you can do. So not all the questions are going to be really complicated like those last two that I did. I actually tried not to ask a whole lot of those, I don't think, on your homework. And then the only other question I wanted to go over here is 13. Not because it's hard, just because it's asked differently. It says compute the exact value without a calculator. And it says f of x equals negative 5, 8 to the x for when x is 1/3. So all you're going to be doing is taking 1/3, plugging it in for the x. And then knowing that 1/3, or sorry, 8 to the 1/3 is going to be what? What kind of root is it?
Cube root.
A cube root. Mm-hmm. All right, so cube root of 8 is 2, and then 5 times 2 is, negative 5 times 2 is negative 10. All right, you do have a lot of homework questions, but the beginning should go by really quickly.
Let's spin a wheel.
We do Miss Paxton.
How many did I give you? 46?
Yeah, let's cut that in half. And it
We
evens.
Let's only do the number 6 and number 7.
Oh!
Or just do 6 or 7.
I will let you omit 10 of them.
Yeah, we get to take away 10 of our choice. Okay,
10 of your
Which
choice.
one are the hardest?
Any 10 you want to omit.
Which one?
All right, sound
So it'd
good?
be like 7, 8, 9.
I'm gonna omit 6,
No.
7, 16, 7.
All right, you can omit 10.
26.
You do have a homework quiz tomorrow. Tomorrow's lesson, I give you 2 days to do tomorrow's lesson. So we'll do the notes, and then whatever time is left, you can work on your homework. And during class on Wednesday is just a full day of working on 7.2.